This lesson is about fermentation, and here are the objectives. In order to understand fermentation, it's important to understand why it's necessary. On the left here, I have glycolysis, the first step in cellular respiration, the splitting of glucose into two molecules of pyruvate. And on the right side here, I have a sort of schema of all of cellular respiration, with glycolysis here as this first vertical rectangle, the Krebs cycle represented by this circle, and then the electron transport chain here as this horizontal rectangle. Now, as we've said in a previous lesson, most of the ATP is generated in the electron transport chain as we have NADH and FADH2 coming from glycolysis and the Krebs cycle. And those are high energy electron carriers that are carrying energy and electrons from the breakdown of glucose to the electron transport chain, and then they are being used to make lots of ATP at the electron transport chain. And as I've written here, NADH is being made in glycolysis, and both NADH and FADH2 are being made in the Krebs cycle. We said in a previous lesson that this whole process of aerobic cellular respiration generates about 30-ish ATP per glucose molecule. Now, on the left side here, I've taken just glycolysis and expanded it. I'm not showing any of the reactions in glycolysis, just the input and the output of glucose and pyruvate respectively. And this process of just glycolysis makes a net of only 2 ATP compared to the 30-ish ATP of the full aerobic cellular respiration process. Importantly, NAD plus is being reduced to NADH in glycolysis. And it's this NADH that I've drawn over here that's then going to go to the electron transport chain where it's going to be used to make ATP. In other words, following this NADH, it comes over here, hands off its electrons into the electron transport chain and is oxidized back to NAD+. This NAD+ can then feed back to allow further glycolysis to go on. So NAD+ is an important reactant in glycolysis. If there's no NAD+, this step can't happen and glycolysis grinds to a halt. Where does that NAD+ come from? Well, it's being regenerated at the electron transport chain. And that presents a problem because the electron transport chain requires oxygen. That's why we need to breathe in oxygen. It turns out that oxygen accepts electrons at the end of the electron transport chain. No oxygen, no functioning electron transport chain. No functioning electron transport chain, no NAD+ being regenerated, and then glycolysis grinds to a halt because it's missing one of its inputs. So the process of fermentation, which we'll look at in just a moment, is a way of solving this problem. It's a way of regenerating NAD+ without a functioning electron transport chain, for example, if there's no oxygen. We'll look at two different types of fermentation, ethanol or alcohol fermentation and lactic acid fermentation. Both of them are taking the pyruvate that was the end product of glycolysis and still contains lots of stored energy and using it to regenerate NAD+. So in ethanol fermentation, NADH is oxidized back to NAD+, not at the electron transport chain, but on pyruvate, turning it into ethanol. And this is what, for example, yeast are doing when they are being used to bake bread or to brew beer, and that's why we end up with bubbles, because this process releases carbon dioxide. But the purpose of it for the yeast is to allow NAD+ to be regenerated so that glycolysis can continue. Even though glycolysis is only yielding 2 ATP per glucose and aerobic cellular respiration is releasing maybe 32 ATP per glucose, 2 ATP per glucose is still better than nothing. So we need that NAD+ back so glycolysis can continue. By the way, notice that this conversion of pyruvate to ethanol is not itself yielding any more ATP. No more ATP are coming out in this step. It's just to regenerate the NAD+. The other kind of fermentation that we'll look at is lactic acid fermentation. And similarly, here NADH is being oxidized to NAD+, regenerating NAD+, to allow glycolysis to continue, but through a different reaction, and this one's producing lactic acid, not ethanol. And this is what happens in your muscles when you are exercising hard enough that you can't get enough oxygen to them. So the electron transport chain's not functioning, we switch to lactic acid fermentation, and lactic acid builds up in the muscles. again, this conversion of pyruvate to lactic acid now is not itself generating any more ATP, but it's allowing glycolysis to continue so we can at least unlock a minimum amount of energy from glucose and generate 2 ATP per glucose. The liver can actually convert lactic acid back into pyruvate, and so we'll clear the lactic acid once we get more oxygen to the system and pump the lactic acid to the liver. So in summary, the purpose of fermentation is to regenerate NAD+, in order to keep glycolysis running in the absence of oxygen. So that's a look at fermentation, including both ethanol and lactic acid fermentation.